Algebra 2, Chapter 4, Section 5. 2 by 2 matrices, determinants, and inverses. All right, using inverse matrices to solve equations. If the inverse of a matrix A exists, you can use it to solve matrix equations. Let's look at this. So remember, in Algebra 2, our capital letters represent matrices. So in the first example, I have matrix A times matrix X equals B. Well, I know I can multiply each matrix or each side by the inverse of A. And what that'll end up being is down here at the very bottom. You can see the different properties of multiplication that we go through to get this. But if the inverse exists of matrix A, X equals the inverse of matrix A times matrix B. Okay, so this is very good for us. So our first example is solve this matrix. And I'm going to write it over to the left, and we're going to solve it. So I got negative 2, negative 5, 1, 3 times matrix X equals negative 2, 2. Okay, so here's our matrix. First question, does it look like matrix A times matrix B equals X? Sorry. Does it look like matrix A times matrix X equals B? Well, yes, it does. So we know matrix X is going to be equal to the multiplicative inverse of A times B. So we've got to find the multiplicative inverse of A. Okay, to do that, step 1. Let's find the determinant of A. Remember, that's where we just cross multiply and subtract. So we're going to find out determinant of A is negative 2 times 3 minus negative 5 times 1. So it's going to be negative 6 minus negative 5, which is going to be negative 1. All right, well, the equation for the inverse of A is 1 over the determinant of A times, for a 2 by 2 matrix, it's D negative B negative C A. So that's just going to be 1 over negative 1 times 3. Again, we're using this matrix up top, A, B, C, D. So our D value is 3. Negative B would be positive 5. Negative C would be negative 1. And our A value is negative 2. Well, negative 1 or 1 over negative 1 is just negative 1. So A prime, or our A inverse, is just negative 3, negative 5, 1, and 2. Okay, going back to X equals multiplicative inverse of A times B, we're going to say X equals our A prime values are negative 3, negative 5, 1, 2, multiply by our B value, negative 2, 2. So our X is going to equal, if we remember our rules, this new matrix, since the first one's 2 by 2, and the second one is 2 by 1, our new matrix is going to be 2 by 1. So first row times first column, it's going to be negative 3 times negative 2 plus negative 5 times 2. So that's going to be 6 minus 10, which is going to be negative 4. Okay, the lower half of this is second row times first column. So that'd be 1 times negative 2 plus 2 times 2. That's going to be negative 2 plus 4, which is going to be 2. So my matrix X is negative 4, 2. So that's the answer to the first example. Matrix X is negative 4, 2. All right, next example. Let's just do one of these. Okay, so number 22 from the book. Solve each matrix equation. So the first one is 12, 7, 5, 3 times matrix X equals 2, negative 1, 3, 2. Step 1, find the determinant of matrix A. It's going to be 12 times 3 minus 7 times 5. So that's going to be 36 minus 35. So the determinant of A is going to be 1. Okay. The multiplicative inverse of A is 1 over the determinant of A. Our D value, which is 3. Our negative B, negative 7. Negative C, negative 5. And our A value, 12. Okay, well, our determinant was 1, so 1 over 1 is 1. So our inverse is just this. So now we can go back to the original equation. So we can say x equals A, multiplicative inverse of A times B. So x is going to equal 3, negative 7, negative 5, 12. That's our A. Times our B value, 2, negative 1, 3, 2. So this is going to be a 2 by 2 matrix. So let's set it up. First row by first column. That's going to be 3 times 2 plus negative 7 times 3. So it's going to be 6 minus 21, which is going to be negative 15. Okay. First row, second column. I'm going to get 3 times negative 1 plus negative 7 times 2. That's going to be negative 3 minus 14. This is going to be negative 17. Okay, now we're going to go second row, first column. Second row, first column. So we're going to get negative 5 times 2 plus 12 times 3. So that's going to be 26. Second row, second column. Negative 5 times negative 1 plus 12 times 2. So that's going to be 5 plus 24, which is going to be 29. So our new matrix X is negative 15, negative 17, 26, 29. Okay. Remember, if the determinant now equals 0, all that means is you don't have an inverse. Okay. Next example. Real quick, let's evaluate the determinant of each of these. So we're going to do it really fast. We're going to cross multiply, so it's going to be 16 minus negative 20, which that would be 36. It's going to be negative 60 minus 60, so it's going to be negative 120. This one's going to be negative 4 minus negative 4, so it's going to be 0. 29, that's going to be 2 minus 0, so that's going to be 2. And 30, that's going to be 36 minus 27, so it's going to be 9. So there are our answers quickly for 26 through 30. Just finding the determinant. Pretty easy, pretty simple. All right, last example. Now we're going to solve a matrix equation. First thing we got to do is try to get the variable by itself. So step 1 is we're going to subtract matrix 2, 7, negative 3, 4 from each side. And if you're good enough, you don't necessarily have to show these steps, okay? So I'm going to get 4, 7, 1, 2 times matrix X is going to equal, so let's just look, 6 minus 2 is 4. 2 minus 7 is negative 5. Negative 2 minus negative 3 would be 1. 3 minus 4 would be negative 1. So there we go. So now we have the equation, looks like AX equals B. So we just got to find the multiplicative inverse of matrix A. So the determinant of A, to see if it exists, is 4 times 2, which would be 8, minus 7 times 1 would be 7. So the determinant's 1. So we love that. So my inverse is going to be 1 over the determinant of A, which is 1, our D value, which is 2, our B value, which is negative 7, our C value, which is negative 1, and our A value, which is 4. So there's my multiplicative inverse. So X is going to be my multiplicative inverse, 2, negative 7, negative 1, 4, times matrix B, which is 4, negative 5, 1, negative 1. So we're going to have a 2 by 2 matrix, so let's give ourselves some room. So it's going to be 2 times 4, 8, plus negative 7 times 1, negative 7. So that's going to be 1. So 2 times negative 5 is negative 10, plus 7 times negative 1 is 7, so that's going to be negative 3. Now we go second row, first column, so that's going to be negative 4 plus 4, so that's going to be 0. That's going to be now 5. Negative 1 times negative 5 is 5, plus 4 times negative 1, 1. So my X matrix is 1, negative 3, 0, 1. Okay? Well, those are all the examples on how to solve 2 by 2 matrices. If you have any problems, just relook the video over and ask questions. Good luck, and we'll see you soon.